This honors geometry lesson, section 4.3, is on special parallelograms. The objective is to know and apply the properties of special parallelograms. A quadrilateral with 4 right angles is a rectangle. Since both pairs of opposite sides are congruent, every rectangle is a parallelogram. A quadrilateral with 4 congruent sides is a rhombus. Again, since both pairs of opposite sides are congruent, every rhombus is also a parallelogram. A quadrilateral with 4 congruent sides and 4 right angles is a square. Notice that every square is a special kind of rectangle as well as a special kind of rhombus. Since rectangles, rhombuses, and squares are parallelograms, they have all the properties of parallelograms. They also have the following special properties. Theorem 4-9 states the diagonals of a rectangle are congruent. Theorem 4-10 states the diagonals of a rhombus are perpendicular. Theorem 4-11 states each diagonal of a rhombus bisects 2 angles of the rhombus. We will take a closer look at Theorem 4-9, 4-10, and 4-11 in our next class. Theorem 4-12 states the midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. Let's say that we have point M, and we have triangle ABC. Point M is the midpoint of AB. So if we make a segment, which we're going to call CM, which is this dotted line here, the distance from CM will be the same distance from AM and from BM. Theorem 4-13 states if an angle of a parallelogram is a right angle, then the parallelogram must be a rectangle. So again, on the left-hand side, the green figure shows you the properties of a rectangle. It also has the properties of a parallelogram, which means that the opposite sides must be parallel and the opposite sides must be congruent. The figure on the right is a parallelogram, but as it stands now is not a rectangle. So let's go ahead and take one side and turn it into a 90-degree angle. Okay. All right. Now what we're going to have to do is move this segment down here, because remember, we still want opposite sides to be parallel and congruent. And what I'm going to do is I'm going to take this side here, and I'm going to go ahead and close my figure, because remember, a parallelogram is a closed figure with 4 sides. Okay. So as you can tell, if I move this around, the only way that I can keep both pairs of parallel sides congruent is to go ahead and make all 4 angles 90 degrees. So therefore, if we have one right angle, by default, all 4 angles are also going to be 90 degrees, which makes this parallelogram a special parallelogram, which is a rectangle. Theorem 4-14 states if 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So remember that consecutive means next to. So on the left-hand side with the green figure, this is an example of a rhombus, which is still a parallelogram but has 4 congruent sides. The figure on the right are 2 segments that are congruent, and what we want to do is we want to show that if 2 consecutive sides of a parallelogram are congruent, then the parallelogram is also a rhombus. So if I take this segment here, and as you can see, it is congruent to the segment here, and in order for this to be a parallelogram, it also has to be parallel on the opposite side. If I take this segment, you're going to see that it is congruent to the other segment. And again, if I make that parallel, the only way for this figure to be a parallelogram with 2 consecutive congruent sides would mean that the opposite sides must also be congruent, and therefore all 4 sides are congruent, which makes this parallelogram a rhombus. This is the end of the lesson. If you have any questions, feel free to watch the video for a second time. After watching the video again, if you still have questions, please write down any clarification questions you may have and bring them to the next class.